Today, let's work on Leetcode 1301, number of paths with matrix with max score. And this is a dynamic programming problem, as it's a lot of hints there because you're seeing a matrix and you're seeing a matrix, and actually you're looking for some max score, things like that. So it's very probably that you're going to implement a dynamic programming problem. And this problem is not so identical with other ones because not only require to output the maximum score, but also you need to count how many paths from the start to end. So it's a little bit tricky, and you need some additional um, vector to store those states, but it's still manageable and won't be so difficult. So let's see what this question is about. So we're given a board. It is a square, so it's n by n characters, and we can move on the board starting at the bottom right square marked with the character s. And this board is given by a list of string, so it's um, a list of strings, so it's not a vector, but it should be identical. And you're starting from this position and want to go to the top left to this position, and all the position with an x cannot be reached. There's an obstacle there, and each grid has a numeric value um, from 1 to 9. And in each move, you can only go up left or go up left, so diagonally. So in order to solve this problem, let's first we say by symmetry we go from E to S. So we do not go from S to E. So this will make the problem simpler. And also we do a change. We put board. If we say the n is a board size, and we set n minus 1, n minus 1, we set it to 0. This will make the calculation even simpler. Then we have two vectors, f and g. F is n by n. And initially, they should be initiated to some very large negative value. So int inf equals 1e minus 1e8. So initially it's to inf, and g is actually with the same dimension as f. Okay, then we can do something else. We can do the dynamic programming process now. So for I equals 0, I less than n plus I. And for each one, we say j equals, for j equals 0, j less than n plus j. For each position, we can initially set f0, 0 to 1, and set g0, 0 to f0, 0 to 0, g0, 0 to 1. So f is the to record the maximum sum. Fij means from 0, 0 to ij, the max sum. And gij means from 0, 0 to ij, the number of ways to achieve max sum. Yep. So the meaning are clear here. So in this case, if I is 0 and j is 0, or fij board ij equals to x, we don't need to do anything, right? We'll just continue. Otherwise, this place is a numerical number, right? It is from 0 to 9 because we have set this position as 0. So in this case, we can update if I, then f ij equals max fij and fi minus 1j, right? Similarly, we do it like we do it for other positions as well. So this is j minus 1. And if I and j, I minus 1, j minus 1, okay? And of course, we need to add the value for this current position. So we say int t equals f board ij. Then we have another variable for g. Okay, g, we first update f here. Then fij plus t, right? Into plus t. This is board minus 0. Okay, then we got fij. And if fij is and we need to find this fij is the maximum sum, and we need to choose g so that it equals to the max, right? R equals fij minus t. Okay, this is the max sum of previous position. So it's top left or top left, 3 positions. So if R equals g, and of course if I and R equals g I minus 1j, then gi j plus equal to, yeah, of course we need a variable here, count equals 0, and count plus equal to gi minus 1j. And similarly, we do it for other positions as well. J, and this is I and j, right? This is j minus 1, this is I minus 1, j minus 1, and this is j minus 1 and minus 1. Okay, then gij just equal to r. And I think that's it. If we found f minus 1 and minus 1 less than 0, it means we just return 0, 0. Otherwise, we will need to return f minus 1, and minus 1, g and minus 1, and minus 1. Okay, let's see. The output is incorrect. It seems we are correcting, we get the correct total sum, right? The max sum is correct. However, the number of ways to achieve this max sum are wrong. Let's see what's happening. So Fij is updated. It's updated to the previous position, right? And then we need to calculate the number of ways to achieve it. So count is set to 0, and I think remember that each position, Gij, it can only be updated once. So we do not need to worry about its existing value because it will be covered by R, replaced by R. So R is Fij minus T, okay? Oh, this should be count, right? R is the previous sum. Count is the actual number. Count. Let's see here. Gij equals count. So if I and R equals, so this means Fij, and Fij is this one or this one or this one, the maximum of all three. So should be right, huh? F board Ij minus 0 is the value of t. So the maximum is Fij minus t. I think this is F, right? This is F. Let's see. Yeah, I think this is correct. So it should be equal to the max sum, not the way to achieve the max sum. So let's submit. Oh yeah, we forgot to do this modular, and we define some number here. 1e9 plus 7, right? And this number should be fine. It won't overflow, but this number is dangerous. So it should be plus plus and yeah, like this. Let's see. Huh? Oh, where is, oh, yeah. So let's try. Okay, it passed. And I think that's it for this question. And thank you for watching. See you next time.